in case you guys didn't know, like this is a little history lesson going on here. So we got the structure of the atom. Okay, so now we're getting to like how this actually looks. Okay, so real fast during this time, right? J.J. Thomson, there he go again. He proposed a model of an atom. Okay, so he was real busy during this time. This model here, right, is what's known as the plum pudding model. Okay, so in this plum pudding model, so Thompson's thinking here, right, that it's a sphere, and in the sphere, right, it's positively charged. All right, so it's all positive, and in the sphere, there's these little bam bam electrons all across this sphere of positive energy, positive charge, right? And this is what the plum pudding model is. Now, of course, right, you know someone had to test that theory, right? Because this plum pudding model is a theory that Thomson came up with. And we know, right, because it's scientific process, we understand, right, that theories can always be tested. They will always be tested. So here comes another scientist, Rutherford here. He's going to do this experiment. He calls this the gold foil experiment. Before we get there, let's talk about a couple of different things. So let's talk about radioactivity, okay? Before we talk about the experiment, okay? So this guy, basically in 1896, he discovered uranium, right? Produced an image on a photographic film in the absence of light, okay? And during this process, he basically found out that this spontaneous emission of radiation was called radioactivity, okay? Now, we can talk about radioactivity at a later time. I just want to highlight three things about it. Okay, the types of emissions. Okay, so we have gamma rays, which are a high energy light wave. We have beta particles, which are a high energy electron. Okay, and then we have alpha particles, which are basically a particle with a positive charge that says twice as large as an electron and a mass that is 7,300 times that of an electron. Okay, so these are bigger particles. Okay, that's all I'm going to cover about radioactivity. If y'all want to know more about it, just let me know in the comments. But yeah, let's do back. All right, so now that we know about those alpha particles, right, let's look to the experiment. So he's going to do this gold foil experiment. All right, so basically, we have our source, right? And this source is surrounded by this lead. And in this source, right, we're going to shoot that energy through here. Now, the gold foil, which is in directly the middle, right, is being shot by this source. And surrounding this gold foil is a detector, all right? Now, this detector is key, right, because this is how we're going to detect, right, where that source is going to go. Is it going straight through or is it going to, right, be bounced off? We really don't know. Now, with this, right, with this gold foil experiment, with this source, he was shooting out alpha particles, right? Positive charge particles, okay? And he was shooting it, it was directed at this thin sheet of gold. All right, it's a thin layer of gold. Okay. Now, what he saw in this experiment, right, was that most of the alpha particles pass through with little or no deflection. Bam, they all go through. Okay, which they hit here. That's the importance of this detector, right? It's all around because we had to detect where the alpha particles was going to go. However, what do we see here, right? A few of those alpha particles were deflected, right, in large angles, right? So all of them did not go through just straight through, right? We got some going out here. We got some going over there, right? We got some going right there, everywhere, okay? So those alpha particles were being deflected. And this is through a loop. It's through a loop. Let's talk about that loop. So initially, right, the predicted results, right, if we're thinking about the model that's out now in the world, which is the plum pudding model, right, is everything's positive charge sphere, and we have these electrons in them. And if you shoot positive charge particles through that plum pudding model of the atom, then basically, right, everything should go through. Every single thing. Nothing should be deflected at all. Okay? But here's the thing, right? People always got to test a theory. We see, right, a few of those alpha particles were deflected. Bam. So this threw a lot of different things off. Right? So, my guy here, Rutherford, he proposed a new theory. All right? So this new theory, we call this the nuclear theory. And this is going to help us determine the structure of our atom now. Okay? So let's talk a couple things here. So let's look at the first one here. Most of the atoms' mass and positive charge, right? So most of the atoms' mass and positive charge are contained in a small core called a nucleus. So Rutherford said that, okay, we got a nucleus, and actually the atom is mainly in this nucleus, okay? And really everything about an atom is in it, okay? So it's not this big old sphere that we all thought it was, okay? Second thing he proposed was that most of the volume of an atom is empty space where tiny negative charged electrons are being dispersed, all right? So we go here, let me look at here real fast. This is how he was proposing this nuclear theory, right? Bam, he said the first thing, we got a nucleus, so it's super small. And actually, most of the mass is actually in this nucleus, so it's not as big as we thought, everybody. And then surrounding that nucleus is our electrons in this electron cloud, okay? So this will make sense why majority of the alpha particles were able to go through, right? Bam, bam, bam. Most of these particles are going through with no problem. However, this makes up for, well, why was some of those, right, particles being deflected? Well, they were hitting the nucleus, right? And once they hit the nucleus, we see them being deflected at a large angle, which we see some shoot off that way, and we see some being shut off that way. Okay. Then the last thing here, there are as many negative charged electrons as positive charged protons. So because of this, right, he also said that the plum pudding, right, it was a great segue to this actual nuclear theory, but this is not a positive sphere, right? In fact, the atom is actually neutral. Okay, so atoms are actually neutral. The only positive or negative we have is because of a proton, right, or the electrons. And later on, he actually redefined this theory to add in the neutrons, which we see here. Okay, so ultimately, he came up with this nuclear theory. And this is our nuclear model, all right, that we're going with here. Key thing, y'all have to test those theories. People been testing theories, all right? People always been tested, all right? That's the reason why people begin pissed off, because you always have to test everything. But it's okay. If people didn't get tested, right, we wouldn't know the knowledge we know now, okay? So please, if you ever being tested, don't get mad, right? There's a reason for it, all right? That's just my little 2 cents in there.